Good day, everyone. I welcome us especially to this session. I think we don't need to wait anymore. We need to just start up. I trust that other people that might join later on, if they're able to meet us, if not, they will be able to have access to the recordings. The recording will be shared on this platform, and at the same time, there's going to be a YouTube link provided for that purpose. So again, the aim or the goal of this program is to raise generations of artificial intelligence experts. So our vision is that within the first 10 years of this operation, 1,000 artificial intelligence engineers, artificial intelligence and those who are actually engaged in the development and designing of algorithms that are used in the field of AI. And not only that, we desire to raise people that are going to be able to play efficiently on the world scale. So we're not fixing our eyes on some people that we just play on a local scale or on a regional scale. We want to have a set of people that will be powered with knowledge, who will be able to help advance the course of artificial intelligence. And as we learned in one of our series, that in the next few years, I think like 5 years or 6 or 7 years from now, there are a lot of trillions of US dollars that are inherent in this market space. And it has been projected that most of this wealth will be created from two major countries. In fact, 70% of it will be created from the United States of America and China. So we want to see how we also could leverage on these great opportunities, because we know that our world is no more going back in artificial intelligence. There are a lot of products that are coming up. There are a lot of breakthroughs and discoveries that are being made. So it's not just to sit and be crying, where's this world going to? The best thing we could do at this point in time is also to proactively participate and not to sit down reactively. Because at the end of the day, the changes are here. And the changes are only going to be controlled by those who have the requisite knowledge. So even though some people are crying wolves that Robert will take over the market space, artificial intelligence will take over the market space, but the truth is still that, according to a book written by Peter Thiel was one of the co-founders of PayPal. He co-founded it then. He merged actually then with Elon Musk, and is a great venture capitalist. And he wrote a book titled From Zero to One. And in that book, he addressed this point of machine computer taking over people's job. So he made it clear that it is a complement. It's going to be a complementary role. And for those of us that have done some studies in the world of artificial intelligence or computers, we know that computers are actually dummies. Even though they are very intelligent, if they are trained properly and they are made to do what they are supposed to do. But in the real sense, they are dummies. They are dummies in the sense that it is what you tell them to do, they will do. They don't have this inherent ability to reason and think like humans would do. And that's what deep learning is trying to do, to make a computer mimic humans so that they can think. But we know that deeply and deeply, they can still not be humans. So they're going to complement us. They're not competing with us, actually. They're not competing with us because we know that all the discoveries that are being made now, they are being made by humans. And the next technological advancement will be built on the current technological progress. So it's still going to be humans that are still going to bring up greater discoveries and optimization of whatever we have at present. So I believe it is not a good thing for humans to just sit reactively and be crying, they are going to take my job, they're going to take my job. In fact, one of the goals of this program is also to raise people that will be job creators, because the age you are in now is not an age where people should just be looking for jobs here and there, even though it's still going to be part of our ecosystem. We can't do without it. Of course, some people will do that. Some people will still need to look for a job. But then we should be among those who will proactively create jobs for others, so that when others are looking for job, we think of how to create a multi-million dollars job opportunity and the market expansion. So that's the reason. And I just have a passion. Normally, I do have passion to help impact knowledge in people, because I know the place of knowledge in anything one does. So I just see this also as an opportunity, because I myself, I am an artificial intelligence researcher and cybersecurity as well at the postgraduate level in one of the North American universities. So I have seen some stuff, and I just feel like the little I have or something I know, I should be able to pass it also across to people, especially the young ones, especially the young people who will be able to go and take over this market space, like Elon Musk of those days, like Peter Thiel, like Mark Zuckerberg, and Sam Altman, the CEO of OpenAI, and many other great guys we have around. And I don't want us to be limited in thinking that, okay, because of my region, I'm from this part of the world. No, we have the brains, and the same brain, we could do greater also. So enough of the introduction and the spicing up. So let's get into the core stuff we have for today. I will not really take much of our time. The target is to have 1 hour for this webinar. So I will see as much as I can to make sure that I wrap up the discussion at the normal time, regardless of when people join. So this is the fifth series in this work we are doing. So we've started it for some time, but I had to have a pause at the time because of some engagement I have with my research work. Then we have discussed some stuff about artificial intelligence, what it means. We've talked about it, what artificial intelligence means, and the applications of artificial intelligence in many spaces. And it will not be a nice thing to start all over again. We have the recordings, we have the videos already, we have the materials already on the platform. We could refer to them and be grounded in those things we have discussed before. Today, we're going to talk about machine learning. And in talking about machine learning, we're going to talk about the algorithms. When we say algorithms, algorithm simply means set of instructions that are given to computers to tell them what they do, the step they need to follow to achieve a particular desire or a particular objective or some set of objectives. So the step by step, as I said earlier on, that computers are dummies. They don't know anything until we train them, until we give them what to do. They are not intuitive like humans. So we need to tell them what they need to do. And it's by telling them what they need to do that they will know where to go. So artificial intelligence aims to do that, to train machines, to train computers on what they need to do. So one of the subset of artificial intelligence is machine learning. And I've explained this also in previous videos. And in this machine learning, we have some methods that are used to train computers, to train machines on how they should do their work. But then I'm going to talk again about the correlations that exist between different methods that are used in artificial intelligence. So on the broader scale, please, can we see my screen? Let me ask that. And if we can see my screen, please, can we tell me what we can see?
Yes, sir. We can see
what is displayed now?
Machine language learning, deep learning, convolutional neural networks.
Thank you for that. Okay, so when we see these intersections of points, or will I say intersection of points, they are subsets of fields. On the outer scale, we have artificial intelligence. That's the, as I like to call it to describe it, that's the great grandfather. So inside of the great grandfather, in him, every person has children that he is going to produce in the world. Millions of them, millions of cells. So inside of artificial intelligence, we have another father called machine learning. So it's a method in computer system that, according to the definition of Andrew Ng. Andrew Ng was one of the he was one of the co-founders of Coursera and a powerful guy in the Google at the time. Was a Stanford University product and a professor actually. So he defined the artificial machine learning as as programming a computer in such a way, programming computer in an explicit manner. So what it means is that I have a computer. I want this computer to do a certain job, to add 1 + 1. I will use that computer to do the job from now on till the end of the world. So I'm going to do something. I'm going to create a program such that anytime I want to use that computer to do 1 + 1 or anything related to that kind of arithmetics, I don't need to be priming it all the time. So once I train it, it should be able to do that job continuously. So that's the non-explicit programming. I don't need to do it every time. So the aim of machine learning is to achieve that purpose such that when you have a program, when you have a model that you have designed for your computer, you should be able to use it iteratively without reprogramming it. So that is machine learning, and machine learning is inside of artificial intelligence. So in artificial intelligence is making computer system to perform tasks that require human intelligence. You make the work so easy for computers so that they are able to think like humans would naturally do. Then inside of machine learning, we have a deep learning. So in deep learning, we have a type of machine learning in which multiple layers of processing are used to extract progressively higher level of features from the data. This seems very big, but what it simply means is this. I have an image of a cat, for instance. In deep learning has some architectural design that makes it able to break down that image of a cat. It will extract the relevant image. They call it feature engineering. It will break down the image of that cat to pieces for the relevant, the most prominent parts of the image of the cat, and we assign some values to them. So after that, it will be able to learn that image and many other images of cats that are sent to it for training, so that tomorrow, or when you deploy that algorithm, that model eventually to a project, it will be able to classify and tell you that based on what I've learned, this image, I can say 70% it looks like a cat, and maybe 20% looks like a dog, 10% it looks like a goat. And we use probability to do that. So based on the higher probability we have got, which goes for cat, so we can ask, okay, on this assumption, we can say this is a cat. And that happens because of what we call the hidden layers, the output layers, the input layers, or the input layer, hidden layers, and the output layer. So we're going to get to those ones also eventually. Then inside of deep learning, we have other methodologies. One of them is CNN. CNN is not broadcasting news. It's convolutional neural networks. We have another one called RNN. That's a recurrent neural network. We have many other ones. So just basically they mimic human brains and they work as humans work, and they make judgments like humans will make judgment. And this makes our world today very, very powerful and very, very efficient. Many of the advancements we are experiencing today, they are built on the foundation of deep learning. And some discoveries that are made from it. So for today, again, we're going to look at machine learning, as I said. Then in machine learning, we have 3 types of learning method. We have the supervised learning, we have the reinforcement learning, we have unsupervised learning. So in supervised learning, we're going to focus on that for today. We have some methods that are used. So we can see that there are a lot of branches from artificial intelligence. We have machine learning. From machine learning, we have deep learning. Then we also have the convolutional neural network. Then also at another side, we have machine learning. Instead of machine learning, we have supervised, we have reinforcement, we have unsupervised. Then for supervised learning, we have some methods like k-nearest neighbor. It is called KNN. Then we have decision tree. We have Bayesian interface. This Bayesian interface is even used in businesses models. It's used in predictions and in some other applications. We have the support vector machine. This one is very powerful. Support vector machine. I wrote a paper on this recently. Then we have on the supervised learning, we have a principal component analysis. We have self-organizing maps. Then we have k-means clustering. So I'm going to just run over this for now. But then there are things we're going to talk on deeply as we progress. So what is supervised learning? What is supervised learning? We ask ourselves. It simply means that set or that type of machine learning method that we use. So what I want us to take note of here is labeled data. Let me try to call something out here. We have labeled data sets. This is very important. We need to take note of this. Labeled data sets. And I'm going to tell us what it means. So another word I'm going to make us to see is predict outcomes and recognize patterns. So those words are very important. So in supervised learning, and the name supervised comes from what it means to supervise. So if I tell you I'm supervising you, it means I'm trying to watch what you're doing. I'm trying to be in charge. I'm trying to control and give you instructions and maybe correct you where necessary. So in this type of a machine learning algorithm, so we have a system, we have a computer system, or we have a machine that we want it to do a particular job. But before we deploy it to do that job, we're going to show it what that job really looks like. When you say the job is well done, what it means, or the information about that particular job. For instance, if I want to design a model that will be able to predict or classify, that'll be able to make classifications about humans, male and female, about what you do. Either I want to buy a house and I want to select a particular area, so I want to predict. So what is going to be the value of this house in this particular area? In London, what will be the price based on this? In Manchester, what's going to be the price? In Abuja, in Lagos. So when you want to compare when you want to make those kind of predictions of maybe the price of the house or the price of cars or whatever you want to buy. So there are certain things, there are some models you need to build. So but before you build that, there is something called data sets. So data sets are, for instance, if I say, let's use a common example. There is something called, there is a kind of data sets in machine learning that is called iris data set. So in iris data sets, we have information about some particular flowers. And these flowers, we have their length, the length of the sepals, their heights. So many information. For instance, human being, for instance now. So in human being, what are the things you're going to have in that data set of a human being? You're going to have the name of the person or the name of the people. For instance, the name of the country where they are from, their citizenship. You're going to have information about their level of education. You're going to have information about their religion bias. You're going to have information about the type of family they come from. You're going to have information about some other things, maybe the food they prefer. So those pieces of information about those particular people or those particular group of people or the particular citizens of a particular country, the piece of information we have about them in an Excel sheet or any other methods of representing information. Those are the data sets. set of data that we have about those people. So if you want to generate data set about me, for instance, you need to know my age, you need to know when I was born, you need to know where I was born, you need to know my parents' names, and some other pieces of information. You could generate as much as 100 pieces of information about me. So that would form the data set about me. So if I want to study trees, for instance, I need to know the type of trees. I need to know the seasonal. Is it a seasonal tree? I need to know where it could grow. And I need to know the height it normally reach, the type of fruit it produces, all sort of information. So when you have those type of information lumped together in a particular Excel sheet or in a particular comma separated version, CSV, or some other text formatting documents, so you say you have a data set about that. So we have thousands of data sets that we use to train. So you need to have them labeled. Labeled is in the sense that this is a cat. Why do I know it's a cat? It has four legs. It has one head. It has shiny eyes. It has a kind of color in the eye, and many other information you might want to tell us about the cat. So that will form the data set of that cat. So you now supply those data sets of the cat as the input to your system, and the system will learn. When you say it's learning, it's trying to study or study that those pieces of information about the cat. So after learning properly, you could do something called testing or validation, and thereafter it will now recognize some patterns. So tomorrow, if you bring another unlabeled data, so that's also very important, unlabeled data. If you bring unlabeled data tomorrow and you say, tell me, what is this? Is this a cat or is this a dog? So it will now it will go back to the repertoire of knowledge it has got, that, okay, based on what I've learned about this particular data set before, so if something has head, it has four legs, it has this, it should be a cat. So based on labeled data sets, is going to be able to predict another data set unlabeled. So we need to take note of labeled data set and unlabeled data set. It's very, very important. Then another thing is ability to recognize patterns. So machines are very good at that. They are very good at, humans are good at recognizing patterns. We are good at that. The machine, they're not that good at that until we train them. So sometimes you're wondering, after listening to after watching a particular product on the internet, or you've watched a movie, or you've watched a tutorial, maybe on artificial intelligence on the YouTube, you just discover that after a while, you'll be getting some information, or you're going to be getting some alerts, or you're going to get some prompts on, oh, can you still watch this? This thing is also related to this. And it will be telling you that those who watch this also, they watch this. For instance, you are on LinkedIn, it will tell you those who follow these people, they also follow these people. So telling you patterns. So computers are able to make patterns from what they have learned. And this happened because of supervised learning. But in unsupervised learning, you just give them training, just give them labeled training to learn the relationship. So they are going to make the prediction by themselves. Just give them data, and after you've given them, because they are unsupervised, so you don't need to tell them how to do it. So by themselves, they will be able to generate. But supervised needs to be given labeled data sets. So that's a particular prominent differentiation between supervised learning and unsupervised learning. And I want us to get it clearly. In supervised learning, there is labeled data sets that you need to supply to the model. But in unsupervised, so just labeled, supervised, unsupervised, unlabeled. So unlabeled. So in unsupervised, just tell it, take this blank. You didn't give it any prior information about the data set because it is not labeled. So by itself, it should be able to form some pattern by itself, and be able to, after understanding some relationships, so it will be able to predict and be able to tell you, okay, based on these things I've learned, without being supervised, without being told, without being monitored, I can also make this prediction. So that's a major difference between supervised learning and unsupervised learning. So in supervised learning, you have labeled data sets that you give as input to be trained on and then to make predictions. But in unsupervised learning, the reverse is the case. You did not give it any labeled data sets. Supervised learning algorithms are given label training to learn the relationship between the input and the output. That is very, very important. So let me pause a bit. Do we have any concern here if I move on? Have any concern? Okay, so let me ask my first question then. Can someone tell us the main difference between supervised learning and unsupervised learning?
Okay, you said supervised learning. According to what you said, supervised learning uses labeled data sets, while unsupervised used unlabeled data sets.
So what do I mean by labeled data sets? Thanks for that. But let me go ahead again. What do we understand? What do we mean by labeled data set? Can you hear me? I'm still asking you. Yes, answer.
Okay. There are a set of data that are correct, like they are. I'm lost.
Okay, don't be lost. You are not lost. That's why you are here. Okay, thanks for the effort. At least you made an effort. So, labeled data sets simply okay. Have you have eaten bread before?
Yes, sir.
How do you know it was bread the day you bought it? How did you know it was bread you bought and not something else?
We were told this is bread.
You were told.
Yes.
Okay, let's say you're in a country and you don't have anyone. What will make you to know that this is a product I need? Something will tell you something about that product. There's a word we use for it. Something that will give you information about that product.
Advert.
So it's label. You have heard that word before in the business world, right? Or in the grocery stores, you say, "Oh, what is the label on that food?" In some countries, they have health label that will tell you the amount of calories in a particular food, the amount of saturated fat in the food. Then they will tell you the amount of sodium, so the content. So they call it label. They call it health label. There are 3 labels, 2 labels, and 1 label, and 0 label. So that gives you information about the particular stuff. So when you say labeled data sets, labeled data sets are data sets that have names. They have tag. So another word is tagging. Tag it. So when you tag it, you'll be able to know that, oh, this is what this is. This is what this is. So like when you go to the supermarket, they will put price label. You have seen price label before, right?
Yes, sir.
So the price label will. Oh, when you see that, oh, this one is $50. It's too much for me. Oh, this one is $10. It's too maybe. This one is 1,000 naira. This one is 3,000 naira. So these are the price label. So those price label give you information about that particular product. So also in machine learning, we have a labeled data set. So the computer has been told prior to starting of work that this data, it is this. This one is this. This one is this. So it learns and make prediction. Thank you for that. Okay, so we can now look at this diagram. If you can see it, so we have that big edge with gear is our model. That's the model. That's the artificial, the machine learning model we want to train. But before then, we have an input data, and the image in that input data, we have image of apples. I hope we can see that image of apples. We have 3 apples in that, and we told prior to the work that these are the images of apple. But how do we tell computer that these are apples? There are facts that apple we have. For instance, maybe we talk about the color, we talk about the shape, we talk about the texture, some information about apple that will be relevant for learning. So we'll describe those ones too. We describe them in the data set. So we have told the model that these are apples. These are apples. Then, after training that model, there is something called the testing model. In the data set you are using, you need to divide them into, sometimes, majorly you need to divide them into two. There is what we call the training data set and the testing data set. So you test the knowledge of the model by those test data sets. Just like in the school, our teachers will come to the class, teach us a particular subject on algebra, give us 5 examples, explain to us, this is how this is done, this is how that is done. That is a training session. Then the man or the woman want to test us. It's okay, everybody, can you solve this classworks? And they give us some work to do. And in that way, the teacher, is testing the knowledge of the students to see how much they were able to understand the concepts he or she had just taught them. And how will the teacher know if they pass? If they really got the concept. If a student scored 40%, she will know that this student needs help. If a student scores 80% and above, or 90%, 95%, she will know that, okay, this person really got to know she really got to get a grasp of this concept. So she will be satisfied that this student, at least based on this test results, has shown that he or she had got the concept that was just exposed to him or her. Also in machine learning, we have training data sets. So we use the training data sets to explain or to teach the model how an apple looks like. Thereafter, we give the model classwork to do, and that's unsupervised label. And we bring an apple that there's no label on, and we ask it, what is this? Normally, the training data set is like 70%, while the remaining 30% of our entire data set will be for testing. So we pass the remaining 30% through the learning, through the model, and we say, yeah, tell me, what is this? So if it succeeds in telling us accurately, that's the word, the accuracy. If it's up to like 95% or 90% and above, so we can say that this model has learned. And that is what we have, prediction. It is an apple. It is an apple. It is an apple. It is an apple. Oh, it is a cat. It is a dog. So no, he means it. But overall, for at least 90% and above, 95% and above, actually very good, it should be able to tell us, or 98%, that this thing is correct. Then look at this. So that's our training and our testing. So we have trained it, we have tested it. But we'll now go beyond that. We'll deploy it in the world environments. See, we'll now bring collections of apple, and we have a banana. We pass it through the model. So the model will be able to classify and say, these ones are apples. And because these are apples, these ones are not apple. So you might not know the name for them, but you just know these ones are apple because of my training, and these are not apple. So there's something I need to bring up here at this point in time. And that's a point of binary. Binary in our knowledge of mathematics simply means 2. So it's a binary number, or you say binary base 2. That's the base of the binary base. So we know that for machine learning, for supervised learning actually to work properly, sometimes some of them are just used for classification. And in classification, we have what we call the binary classification, and we have what we also know as multi-classification. That's multi-class classification. What do we mean by that? Anytime you are classifying 2 objects, male, female, dog, animal, maybe plants, boys, girls, school, grocery, just two classifications. So you call that classification binary classification because it involves just two categories. But then we could have more than 2. We have 3 things lumped together in the world today. Maybe we have millions of things we have together. For instance, on our Facebook, we have a lot of information that are lumped together. And in there, binary classification will not do the job because our word is not the word of binary. What I mean by that is things that we do in the world. We have multi-million things that we do in the world. So we have a lot of things we classify. Binary classification will not suffice our real world situations. So in machine learning, we have some algorithms that uses binary classification, but then they are limited because our world is not a binary world. Our world is a world of multi-class. So we also have actually some other algorithms that use multi-class classification. Then there's something again we need to know about supervised learning is the idea of classification and regression. Classification and regression. Okay, let me try and make this clear. In classification, our job is just to separate between Ade and Ujo, Bola and Kike, church, mosque, house, market. But beyond that, we also need something called regression. Now, how do you think that countries like the United Kingdom, no, they will tell you that based on our projections, we have seen that our resources will not be able to support population growth in the rate we are going now in the next 10 years. So they will make a policy. They will say, don't do this again. They will say, those who are coming to the country, like they said recently, don't bring your spouse again. Because they have seen that if the population explosion continues the way it's going in an exponential manner, a point will be reached when they will become jungle deserts. Because their resources will not be able to take care of their people again. So some other countries, they will say, okay, based on our analysis, we have seen that our birth rate, if it continues the way it is now, we will not be able to take care of our children. So we peg it to 2 children per a family, 3 children per family. And the user want to monitor their economic growth and many other growth. Then some other policies might come that, okay, this school, because of our capacity, the lecturers' capacity, the professors, the number of professors, we cannot take more than 50 students per session. Now, I'm giving these examples as things. One thing you will know about these examples I've given is the dynamism. That means the fact that there are things that change. For instance, if a man is a man, forget those who tell lie. A man is always a man. If a woman is a woman, if someone is born as a woman, she's always a woman. There's no change. There's not going to be any change. So that one is fixed. If something is an apple, it is always an apple. So in that regard, things that are fixed, we use classification to classify them. But the world we deal with, or the world we deal in also, is a world of change. For instance, the stock market today, for those who are used to Naira, we learned some days ago that the amount of Naira to dollar is this, then tomorrow is volatile. It changes again. So that is constant change. And in that word, I'm trying to explain what we call regression. So that kind of machine learning model, we use regressional model. So it's very, very important because you might get a project to design a model that will be used by a government of a country, of a state. So you need to be able to know what kind of data set am I dealing with. Am I dealing with things that deal with change or things that are fixed that I just want to classify? I just want to put them in classes. This is in class A, this is in class B. Or are there things that change continuously? So those ones, they are regressional model. So in supervised learning, we use supervised learning to handle 2 types of projects. We have the class for classification, and we also have for regression. Please, this is very important. If you don't take anything from here today, please, it will be fine. We just take this out. Classification and regression is very, very important. So regressional models are models that deal with things that change, like stock price, like a forex, like birth rate control, like death rate, like the amount of immigrants we should bring into our country, like the amount of students we should employ, we should admit into a particular university, like those kind of things, like the amount of visitors we should allow to this capacity, to this facility, based on some projections we have seen or we have made. Okay, that's a key point that we should take note. Okay, then we see something else. How does supervised learning work? I've talked about this. Let me just talk about it again. How does it work? Supervised learning, or maybe let me ask it. Okay, don't worry. How does it work? So we have in supervised learning, we have labeled data. So in labeled data must have examples of the features and the outputs called the label. So we need to take note of this as well. Take note of the input. I've talked about the input, and another thing that you can call your input is features. Features like the characteristics. Characteristics, they are just English words. Features, the characteristics of the input. Like I said the other time, for instance, I as a person now, what are the features about me? You need to know my name, you need to know my date of birth, you need to know some details about me. So if you have those 10 details about me that are specifically unique to me, you could tell, you could predict the label. So the label, you could say, this is she, based on these things that I have known about this person. This is who you are. This is you. You know, sometimes when we maybe lose maybe we have lost something about our account details and we made a call to the bank, they'll just ask you some unique question. They'll say, what's your date of birth? What's your mother's name? They will ask some set of questions. And once you're able to answer those questions, they could say, okay, to a large extent, you are the original owner of that account. And they will give you the information you are asking for. So those questions are to find out your features. And these features, you supply them when you were registering. When you were registering the accounts, so you give them those features. So it is those features they will now use to judge you tomorrow. So even if you are the bona fide owner of that account, but if you could not answer those feature questions accurately, that person will lose that account, because the label on that account shows that if he told, if he's able to tell us clearly the name, the date of birth, the mother's maiden name, the password, and those stuff, if he's able to answer those ones very well, then he's a owner. That's the label, the output. But if not, he's not. So we need to take note of that. In supervised learning, the label data, the label, or the input data, they also call the features. Features. In most of the algorithms we'll be using, I'm emphasizing this because in most of the algorithms we'll be using, we will see features and we see labels. Features, labels, features, labels. They are very key. Features, labels. So features has to do with our input data. The features, the characteristics of the data. The cats, what are the characteristics? Those are the features. Then the labels, the name of that is just one. It's either 0 or 1 for binary, or for that a particular categorical word. It's a cat. So it depends on what you are dealing with. Either 1 or 0, 0 or 1. That's when you are dealing with binary, or you classify or you make a prediction of a particular value. So please, let's take note of that. Features and labels. So features are the characteristics of the input data, while the outputs are also known as the labels. So the data used in supervised learning is labeled, meaning that it contains examples of both inputs, called features, and correct outputs, which is called labels. Also, the algorithms analyze a large data set of these training pairs to infer, to conclude what a desired output value would be when asked to make a prediction on new data. I've already explained this one. Okay. For instance, now, let's pretend you want to teach a model to identify pictures of trees. I've given an example of apple. You provide a labeled data set that contains many different examples of types of trees and the names of each species. I talked about the iris data set. Okay. So you let the algorithm try to define what set of characteristics belong to each tree based on the labeled outputs. You can then test the method by showing it a tree picture and asking it to guess what species it is. Okay. So the next level is this. I talked about this as well. If the model provides an answer, if the model provides an answer, so if the model provides an incorrect answer, you can continue training it and adjusting its parameters. You know, I talked about, I use an example of a teacher that taught a class. So let's say we have 10 students in that class. And at the end of the class, after giving them the test, the teacher found out that just 2% of the class scored 90% and above, with the rest of the class scored 40%. Like we learned recently that in the just concluded JAMB, I think they said 76% of students that scored below 200%, that scored below 200. So that shows to us that the economic, the educational system is in warped state. So it should have called for, some people should have actually resigned, like some ministers should have resigned, there should be resignations in many places in an ideal situation, because for 76% of students to have, and some of those that passed, some of them would have cheated. We know the system. The point is this, that in that kind of situation, it shows a large and gross lack of capacity in the education system for 76% of students to have failed a national exams that prepares them for universities, to have scored below 200%. I mean, below 200, that's below 50%. Because if that is the pass mark, then there should be a declaration of state of emergency on the state of economy. But on the state of education, but what I'm saying in essence is this, that you need to analyze, you need to see at the end of the day how many of the predictions were accurate. So if you have 40% as the accuracy of your model, you will know that there is a problem. So you now need to retrain. Now, in this retraining, there are some things called hyperparameters, and we call it hyperparameter tuning. Now, you've used that word before, fine tune. They say fine tune, fine-tune it. That means change some things, increase this, decrease this, lower this. So fine tune it. Sometimes somebody will tell you, I'm fine tuning my answer to give you the accurate thing. So also in machine learning, there's need to fine tune at a particular place. When you see that your output, the prediction your model is making is not accurate, it's not enough. And when we say accurate enough, we have 95% and above. So you need to fine tune some stuff. And sometimes it might just be, for instance, it might just be that you convert some numbers to some lower numbers and your result will be fine. So, but the point is that you need to start adjusting. And through the adjustment, you'll be able to get to a stage where your model is able to predict accurately. So it's very important. And the essence is that you want to improve your accuracy. So you want to improve your accuracy so you could minimize error. You improve accuracy so as to minimize error. Accuracy is one of the metrics we use in machine learning. Okay. I hope I'm making sense. Can I get some feedback? I want to round off shortly. You said?
Yes, sir. We are getting it, sir.
Okay, sir. Thank you. Now, I just want to show one or two pictures. I've already talked about the main things inside of supervised learning. I'll be trying to round off now. So just look at this. I just use different images to drive home the message. They're still saying the same thing. So here in the supervised learning model, we have an input raw data, and this input raw data could be anything. In this, you could see some shapes, some geometric shapes. You have a circle, you have triangle, you have square. I think you have three shapes. You have a square, you have circle, so you pass them. These are they are the input data, or I give another word for it, features. Input data or features. So this triangle, rectangle, triangle, square, and the circle. Many of them, plenty of them. And that's one thing about machine learning. For your machine learning algorithm to be very, very accurate, you need a lot of data sets. For instance, ChatGPT, that is very, very advanced in large language model today, has been trained with trillions of data. Trillions, a lot of data they use. In fact, for many months or years, they have trained the model. And that's why it's able to perform at the level it's performing now, because of the amount of data it has been exposed to. Sometimes when you ask some questions from the model, it will tell you, based on my last training, this is what I know. It will tell you that if you are using ChatGPT 3.5, the free one, it will tell you that my last training was, I think, January 2022. So he said, based on this training, I cannot give you this answer. Because as I told you, computers are dummies. It's human beings that can reason in far what they have not even seen before. But it's what you train your computer that it will tell you, your model that it will tell you. So ChatGPT 3.5 will tell you that based on the question you are asking now, I don't have the answer because I was not trained on that. So the emphasis I'm making is that you need large data sets for training. So when you want to select a particular model, or when you want to carry out a particular project, you need to determine, you need to be sure. The first question, or one of the first questions you should ask yourself is that, what type of data set am I going to use? And how voluminous is that data set? And then sometimes something might be voluminous and it will be useless because there are a lot of redundancy. So what do we mean by redundancy? Redundancy just means simply you have a particular animal, let's say cat, for instance, and it is the same cat, 100 cats that has the same feature, the same thing, nothing changes. So it's like you have repeated one thing 100 times. So the remaining 99, they are redundant because they're not giving you new information here. That's it. When you are including an element in your data set and it's not giving you something new, it's just what you have known before about that particular image or about that particular object. We call it a redundant object because it's not telling you new thing. And you need to know the essence of having many data sets, or to have many information about it, to have many features in a data set, is for us to be able to pick differences, not just to have it for having sake. So if one will give you if that one thing is giving you what the other 99 are giving you, it's as good as having one. And in fact, in one of the ways to improve our accuracy, there's something called data pre-processing. So in data pre-processing, we remove redundancy. So we search through data set to see anything that looks alike. And if there are 100, we remove 99 and keep one. Because when you have many data sets, it also brings problem to your computer. You have problem with space, storage management, or memory management. So why do I need to keep 99 things if one thing will serve the objective? So it's very important you know that also. Okay. Then after that, as we have explained before, you have a supervisor, you have training data set, then you have the desired output, then you have your algorithm, it processes it, then it gives out output. So you can see at this output, you have you can see that these clustered images have been separated, they have been classified. Now, let me ask you this question. This example, is it, number one, is it a classification example or is it a regression example? I need an answer. This example that is shown, this model that is shown, is this a classification model or a regression model? I need an answer. Is it a classification model or regression model? Anyone can answer. Okay, I can't hear any voice. Okay, let me just go ahead. I think it's basically classification. And in this, we have been able to classify geometric shapes. We have triangle, we have a circle, and we have squares. So that is the first question. It is a classification. Then the second question I would have asked was that, would have been that, is it a binary classification or multi-class classification? And by the way, it is a multi-class classification because it's more than two. The output labels here, the labels, they are more than two. So it's multi-class. That means more than two. It's not a binary. If it were binary, it would have been two. But in this case, we have three outputs. So this is a multi-class classification. Okay. So I will like to call it a day here. The other slides I have, they're just using different images to represent the concepts we're trying to pass across. So machine learning, we have a supervised learning, unsupervised learning, reinforcement learning. So then again, another image, you have supervised learning, then we have unsupervised learning. So this is machine learning at the top, supervised learning, unsupervised learning, reinforcement learning. So today we have dealt with classification, we have talked about regression. So regression or estimation, I talked about that. Then later on, we'll be talking about neural networks, support vector machine, and others. Then we have unsupervised learning. So we have clustering or prediction. We have K-means, Gaussian, mixture model, and other methods. So these are the models we have. And this is where we're going to call it a short today. We're going to bring an end to our work today. So again, you see this supervised learning, you have it being used for classification and for regression. And I've explained what that means. Regression or estimation, something that is changing, something that is dynamic. So you have a value for you today and tomorrow it has changed. Then classification, just to make separation between classes, either binary classes or multi-class classes. So I will give the floor now to anyone who has a question, so we could wrap up the discussion for today. Do we have any question as we call it today? Any question? Okay, thank you then everyone for joining this afternoon, this session. We're going to end our class here today. We are free to reach out on the platform if you have any question. Cute. Just ask your questions there or ask for any clarifications. Thank you so much. God bless us.